Okay, so further explaining this model, this right here is Bose-Einstein condensate. It's going to become a Bose-Einstein condensate. This is absolute zero. The electrons are spread so sparse that you can imagine its buoyancy, it's completely buoyant, but it still contains its energy, which is everything in the universe, conservation of energy. So it's in a lattice, just electrons themselves, because everything is the electron. And these electrons, as it condenses, they're going to stick together because you have properties of a superconductor at this point. And this is basically the theory of everything, because all of this is before the math. The math is right here on. The singularity and everything prior to that and how it formed is everything here in the cold. And by understanding cold nature, because the universe is just basically cold, we can understand how to apply the math here. Because it's not about the math. It's about the concept, understanding how temperature works, then applying the mathematics to it. But first we need the fundamental framework. Now you have to understand space itself is basically a hole. It's the absence of the surrounding area, but there is no surrounding area either, so it's just a straight black hole. And a real black hole that we measure within the universe is actually a quantum mechanical superfluid of, say, helium-4 or deuterium. Helium-4 is a Bose condensate. It slows down or stops light. Light can't traverse through a Bose-Einstein condensate, essentially, because there's no consistency. In a void or space, there's a consistency to allow light to travel. Light can't travel through solid matter. So in this aspect, you can imagine this Bose-Einstein condensate is like solid matter, but it's not, because it moves through itself and fluid and flows, giving no consistency to the light for it to actually traverse. Now, I explained in the video spatial value. You can't quantize space, but you can get a value for it.
Now, if you make certain materials cold enough, something peculiar starts to happen with the electrons. They form pairs, like they don't literally stick together, but they become coupled in some kind of way that makes that they can move through the material freely, and so they don't bump into each other and they don't get scattered, and so your material becomes superconducting.
And that's here in this lattice that I was talking about, where it's sparse and basically buoyant. When it starts to condense, this is what's going on. The electrons aren't necessarily sticking together, but they're being crushed into a focal point. As I explained on the last video, this right here might have spatial value in it when you zoom in on it, but if you zoom way out, it looks like just a big mass because the space is negligible. See, we can prove through cold physics that there was a whole era before the singularity. And that whole era that I'm talking about in this lattice, this sparse lattice, would be the Planck epoch, but it's just electrons. Because like I said, everything's the electron. We know that. This is a theory that's literally prevalent. Their chronology is a little messed up. Now, I'm not saying none of this is true. I'm saying they have spots in here that are inconsistent with what we observe in physics.
Done to understand the universe, we bring out our math books with all our theorems in physics, and they turn to them and say, math, we tried that. It takes you just so far. The real way to do it is like this.
Yes, it's thermodynamics. The numbers are only going to take us this far. We have to understand the water cycle, and that's as easy as the universe is. It's a water cycle. It's a big, giant quantum water wheel. As I've said, Michael Faraday was an accomplished physicist and chemist, but he didn't do math. It's not that the math isn't necessary. To understand how to replicate it, we need the math. But fundamentally, if we want to understand it, the math isn't going to help us understand it. We have to understand concept of how the physics work together.
There is a related quantum effect that also happens at near absolute zero, and that is superfluidity. A superfluid really does seem to break the laws of physics as we know them.
Not really.
If you would leave it in an open container, it would slowly creep over the edges and leak out. It would also seep through microscopically small cracks in its container, and if you would stir it, it would basically keep spinning forever,
Zero
or
viscosity.
at least as long as you can keep the material cold enough.
Because whenever it's condensing, the condensate, there's no resistance in space. It's got zero resistance. And at this point, it's got zero viscosity. So you have to consider the fact that it's a singularity. All the particles in the universe had to be combined in a single unit. And as I mentioned here, when you have the pion between the muon and the tau, that's trying to induce a color charge. This would be around 2.7 K, which is the universe's current temperature. So it's going to go from absolute zero and it's going to start getting warmer. It's still cold at this point. 2.7 Kelvin is still pretty damn cold, but it's warmer than absolute zero. And eventually it's going to get really hot, the hottest it's been ever. All that spatial value has decreased to make it dense also. Because at this point, in this lattice, in this giant electron cloud, it's very unstable. All right, now, this right here is going to indicate that the universe is going to be a cyclical cycle. It's a cycle. The helium is very important because that's what ensures that it's going to reformulate. So if it starts with just electrons and a universe lives and dies, it's going to be easier to form because a universe already existed. It's going to have materials there remnant of the prior universe.
So the quantum effect that causes superfluidity is overcome. Now, superfluidity is a very specific phenomenon that only happens with liquid helium. Helium is quite special because it basically never freezes.
Now, this is a clue into black holes. Now, a black hole isn't nothing. It's not a hole because the space area around it is a hole. That means a black hole is actually not nothing, but it's actually something. Now, here's a black hole. What's its temperature? Negative 459.67. That's near absolute zero. So we have all the physics we need. We just need to put it together. Now, I'm not trying to be an ass, but I don't understand what's so hard about it. All you have to do is know how a stove burner works. Prior to the singularity, this is all potential energy. It's cold potential energy. Just like this burner, it's plugged into the wall. That's its potential energy. Once I activate it, it's going to start getting warm. Then it's going to reach its hottest. Once I'm done with it, I'm going to turn it off and it's going to start cooling. 5 simple stages. Cold, warm, hot, warm, cold. If we keep listening to people like this tell us what to think, we're never going to understand how to think.
Because of helium-4's specific nature, if you cool it all the way down to 4 Kelvin, all the helium-4 atoms fall into the same low energy state, and they all start to behave in the same way. They no longer bump into each other and all move in unison. And so it flows out of its container and will spin forever if you stir it. This really is completely amazing because it's a quantum effect that we can see happening with just our eyes. Even if it needs very specific circumstances, so you'll probably never find it in nature.
Yeah, the specific circumstances are prior to the universe. You have to remove all the heat from the universe and you'll get this. Now, as explained in the video, the last video, it goes from an uncertainty to a certainty because we can observe this coherent superposition, which is the universe. Now, if something is tiny and huge at the same time, that's a superposition. If it exists and doesn't exist simultaneously, like space does, it's a superposition.
Because of the uncertainty principle, it's not possible to know all properties of a particle, so it's more realistic to think of it as more of a vague blob or tiny cloud.
So all of these particles and the singularity in the universe, all of it, it's a wave. But this is also a heat equation, which ties to Schrodinger's equation, which is a wave and a heat equation, because of superposition and the fact that the universe is a thermion.
Or a little wave packet. Because in quantum physics, particles are waves, and this wave function is where we more or less expect the particle to be. Its true position can never be known with 100% certainty, so the best approach is to imagine it as a cloud or a wave of probability with its own energy identity.
So as I mentioned in the last video, prior to the singularity, that's the probability amplitude, which is Q, because it's unobserved. The Born probability is the singularity itself, and the coherent superposition is certainty, because we know that the universe exists, and we know what we can measure now. That's where the math is what it is. We know. So Eigenstate R equals observed.
If you find this impossible to wrap your head around, that's just quantum physics for you.
So there's that, it's not supposed to understand or be understood. It's not supposed to make sense. That's bullcrap. It does make sense if you have a perspective that is correct and not an obscured perspective as these people enforce. Now, she's not her particularly, but the people in charge, the big people. Look, knowledge is power. Do you think they're going to give their knowledge away? No, they're not. That's them giving power away. As long as they reserve some information for themselves, they can ensure they have more power over us.
Down into the nanokelvins, their energies start to approach their lowest point, and these little wave packets grow bigger and their wavelengths become longer. Now, at about 50 nanokelvin, these waves start to overlap and blend into each other, and they start to behave as if they were one big atom.
One big atom. That's a singularity. So it all loses its identity. There's no individual anymore. It's all one cluster. And the wavelength is going to get longer because it starts tapering off, because it's gaining entropy at this point, whereas prior to the singularity, it's losing entropy. So it's basically got an inversion wave here, and I explained that on another video.
Atom. They don't become solid, to be clear. It's just that all these atoms lose their individual energy identity and you can't tell one from the other, and so they condense into this single collective quantum wave. The only possible in laboratories because we don't know of any natural circumstances that could cause it.
Yes, we do. We're just not told the circumstances. The circumstances are remove everything from the universe where you have only absolute cold, dark, infinite void space. I'm just saying, the physics aren't hard to understand because the universe gives us all the clues we need. I'm the one that predicted that the universe is at least 20. Also predicted that dark energy loses its momentum. Everybody's like, oh, you're crazy, you're crazy, you're crazy. And then lo and behold, fractionally, it does lose its momentum. And it only applies because natural physics indicate that what goes up must come down. So I'm not spouting crap. It's really easy to understand. We're just not told in a way that we can understand. Scientists like to make it sound unbelievable. So it's hard to believe.
Nature and behavior of black holes and neutron stars.
Now, to elaborate on the neutron star aspect, this quark-gluon plasma, which is the singularity, is a neutron star, a macro neutron star. It's neutral because space, like I've said, is 1 and 0 at the same time. Simultaneously, it's a superposition. It's 1 and 0, making it neutral. So as I mentioned before, that the singularity in the universe, everything inherits traits from space. And that's why we have traits that we inherit from our parents. Space is the parent to the universe. The universe is a parent to us. A parent literally, and it's a parent because we can observe it. So when the singularity forms this quark-gluon plasma, it's a macroneutron star. But that macroneutron star starts releasing electrons and protons as it decays and inflates. And eventually it's going to end up as a deuterium star, which is at its coolest. It's going to have a nucleus and a photosphere. It's going to be a giant macroatom. So as it inflates, and protons and electrons are released from the nucleonic matter, you're going to get hydrogen isotopes. So it's going to be essentially hydrogen 7, then it's going to be hydrogen 6, then 5, then 4, then tritium, then deuterium, then protium, and then boom! All of these hydrogen isotopes are a countdown before it goes into what is the inflationary Big Bang, which is basically the parent star emitting smaller stars of itself, smaller copies. Everything emits smaller copies of itself. Everything that exists does that. And that's where we inherit traits. So the smaller copies of itself, the universe does the same thing, and it inherits traits. So you have to apply biology to the universe because that's basically where we get all of our traits. We get fractal veins of plasma just like the universe is. It's a light entity. There's organic matter scattered all throughout it. That's where we get our properties from, and Earth gets its properties. So as long as we keep looking at it like it doesn't matter or it doesn't exist or we don't exist, we're taking value away from it and looking at it in a superficial kind of way. But it's all connected. The universe is a consistent pattern that just repeats itself on different scales over and over and over. And it's really obvious to see because it's all Y and X. It's all Taoistic. So we do live in a static universe, but there are fine lines that we need to draw. We keep relying on Einstein physics, and I'm not saying Einstein was wrong, but it was incomplete. It's a 100-year-old theory, for God's sakes. In contrast to this model, Albert Einstein proposed a temporally infinite but spatially finite model. You can't have a temporal field, which is temporary, infinite, and space itself finite. That's exactly reversed right there. That is literally perfectly exactly reversed. The temporal field of the universe, which is the three-dimensional realm within four-dimensional time, is infinitely finite, which means it's finite in this stage, then it converts into another stage, which is energy. And it converts energy, matter, meaning it's infinite because it does this forever, but it's only in each stage for a finite amount of time. But the space around it is eternal. It's literally infinite. So that's a perfect misconception right there. Now, like I was saying, we have to draw lines. We're going to have to specify specific things. Now, they say it's not static because it's neither, they say it's expanding or contracting. So if it's doing this, it can't be static. But they're not considering on a higher dimensional realm that it's going to be doing this forever, whether it's expanding outward or contracting inward. It doesn't matter. It's going to do that forever. Not to mention particles themselves move. Now consider this as a ball. This would be the universe. Now, if all the atoms in this, they're moving. This right here it's made of matter, and that means there's vibration, fluxes, energy, particles that are moving within it. But it itself is just sitting here still. So the universe might have moving parts within it, but itself is not traveling through space like this. It's sitting static in its own position within the lattice of space, and or the multiverse, you could say, because space connects to the multiverse. The multiverse is everything that is within space. Space just goes on forever. So there are fine lines that need to be drawn. We need to specify things. We need to break things down a little bit further. And why don't geniuses have common sense? This is because their brains are wired to understand and master complex ideas, patterns, and systems. But when something disrupts these patterns or systems, it can be hard for them to adapt. Yes, smart people lack common sense. Intelligent people often override common sense with their considerable brain power. Now, I'm no genius, but I have a lot of common sense. And common sense complements the genius. You have yin and yang. We live in a binary universe. It's essentially a binary dot matrix as a vector field. Because prior to the singularity, this is all your scalar quantity. This is the scalar field. Quantum chromodynamics. This is your vector field. This gigantic electron cloud has magnitude. That's the main portion of it. It's magnitude and magnetic. Electrostatic is more fundamental than electromagnetism because you have disorder of electrons, which are electrostatic. You put the electrons in a line, now you have uniformity, which is electromagnetism. Not to mention the fact that positive and negative forces are static forces that stick together. That's what the strong and weak force are anyway. So gravity itself is the most fundamental force essentially, but it's all electrostatic. So there's either only one fundamental force, which is electrostatic, which is ties to gravity, and gravity isn't hard to figure out on either. I mean, if you want that, I can explain that too, because it ties to simple fundamental physics. Or there's really 5 fundamental forces: the strong, the weak, gravity, electromagnetism, and electrostatic. But electrostatic is the primary force that drives the whole universe. And that's what gravity and anti-gravity are. They're either a condensation, which comes together, or they're an expansion, anti-gravity, which flies apart. Centripetal force compresses in, centrifugal force slings out. So essentially it's taking something complex and turning it into a very basic, fundamental, simple to understand theory that anyone can comprehend. Anyone.